Motherboard and buses. Here is your same structured beginner-friendly content for motherboard and buses. Intermediate level. Understanding system communication. Introduction. The motherboard is the central platform that connects all components of a computer. However, simply connecting components is not enough. They must also communicate efficiently. This communication happens through buses, which act as data pathways inside the system. At the intermediate level, this topic focuses on how the motherboard connects components, how data flows between CPU, RAM, storage, and devices, what buses are and how they work, how communication affects performance. Understanding motherboard and buses is essential for learning how a computer functions as a complete system. What is a motherboard? The motherboard is the main circuit board that connects all hardware components. In simple terms, motherboard equals central hub that connects and coordinates all components. Example concept: CPU plus RAM plus storage plus GPU plus PSU means connected via motherboard, key components on a motherboard. The motherboard contains slots, connectors, and circuits for all components. CPU socket holds the CPU, allows communication with other components. RAM slots hold memory modules, connect RAM to CPU. Storage connectors, SATA for HDD SSD, NVMe, M.2 for faster SSDs. Expansion slots, PCIe, used for GPU, network cards, etc. Power connectors receive power from PSU. I/O ports, USB, HDMI, Ethernet audio. Example concept. Motherboard means connects all hardware parts into one system. What is a bus? A bus is a communication pathway that transfers data between components. In simple terms, bus equals data highway inside a computer. Example concept. Component A means bus, means component B. Why buses are important. Without buses, components cannot communicate. CPU cannot access memory. Data cannot move. Example concept. No buses means no data flow, means system fails. Types of buses. There are three main types of buses: data bus, address bus, control bus. Data bus transfers actual data between components. Function carries instructions and results, moves data between CPU, RAM, and devices. Example concept. RAM means data bus, means CPU address bus. Carries the address location of data. Function tells where data should be read or written. Example concept. CPU means address bus, means memory location. Control bus. What is control bus? Carries control signals that manage operations. Function read-write signals, interrupt signals, timing coordination. Example concept. Control signals means coordinate data transfer. How buses work together. All buses work together to complete data transfer. CPU request means address bus, means data bus, means control bus. CPU request means address bus, means data bus, means control bus. Step by step. CPU sends address via address bus. Control bus signals read-write. Data bus transfers actual data. The combination of all three buses is called the system bus. Example concept. System bus equals data plus address plus control. Modern bus systems. Modern computers use advanced bus technologies. PCIe, Peripheral Component Interconnect Express, used for GPU, SSDs, expansion cards, high-speed communication. Memory bus connects CPU and RAM. Front-side bus, older concept, connected CPU to memory, replaced by modern architectures. Example concept. CPU, memory bus, RAM CPU, RAM PCIe, GPU chipset, motherboard controller. The chipset controls communication between components. Example concept. CPU, chipset, peripherals. Functions of chipset manages data flow, controls I/O devices, connects CPU to storage and ports. Data flow example. Opening a file. User clicks file. CPU sends request. Address bus identifies location. Data bus transfers data. Control bus coordinates. File loaded into RAM, bus width, and speed bus width. Number of bits transferred at once. Bus speed. How fast data moves. Example concept. Wider bus plus higher speed means faster data transfer. Bottlenecks in bus system. If buses are slow. CPU waits for data system performance drops. Example concept. Slow bus means data delay, means performance bottleneck. Advantages of motherboard and bus design. Advantages include efficient communication, coordinated system operation, modular hardware design, easy expansion. Example concept. Efficient buses means smooth system performance. Limitations and challenges. Challenges include limited bandwidth congestion with multiple devices, compatibility issues, complexity in modern systems. Example concept. Too many devices means bus congestion concepts learned. What a motherboard does. How components connect. Types of buses. How data moves in a system. Role of chipset and system bus. Simple definition. Motherboard and buses. The motherboard is the central circuit board that connects all components, while buses are communication pathways that transfer data, addresses, and control signals between them. Final summary. The motherboard serves as the backbone of the computer, connecting all hardware components into a unified system. Buses act as communication pathways, enabling data transfer between the CPU, memory, storage, and peripherals. Together, they ensure that the system operates smoothly by coordinating data flow and execution. Understanding motherboard and buses is essential for learning computer architecture, system design, and performance optimization.